In this video, we're going to discuss Boyle's law. Boyle's law is a gas law that deals with pressure and volume of the gas. P1 is the initial pressure in atmospheres, torrs, or millimeters of mercury. V1 is the initial volume in milliliters or liters. P2 is the final pressure with units matching P1. And V2 is the final volume. Units can be matching or not. We can convert from milliliters to liters and vice versa. So let's take a look at an example. Here we have a question that says, if you have 250 milliliters of oxygen at a pressure of 1,200 millimeters of mercury, what would the volume be if the pressure were changed to 200 millimeters of mercury? So I have volume and pressure. That means I'm going to use Boyle's law. And my pressure is decreasing, so my volume should be increasing. So let's see what happens. There's my Boyle's law formula. I assign my values from the information given. I start with a pressure of 1,200 millimeters of mercury and a volume of 250 milliliters. I finish, or I have a final pressure of 200 millimeters of mercury, and my final volume is what I'm looking for. So I'm going to take these values, substitute them into the formula. I'm trying to isolate V2. I'm going to divide both sides by 200. So I plug this into my calculator and I end up with V2 equals 1,500 milliliters. Units match what I started with because I've made no conversion. Did the volume increase? Yes, it did, quite a bit. So that's a little sanity check. Let's take a look at another problem. So in this problem we have, in an underground gas reserve, a bubble of methane gas has a volume of 45 milliliters at a pressure at 1.60 atmospheres of pressure. What volume in milliliters will it occupy when it reaches the surface where the atmospheric pressure is 0.98 atmospheres? So again, my pressure is decreasing, so we would expect that bubble of methane gas, the volume, to increase. Because this problem only uses pressure and volume, again, we're using Boyle's law. So I have to pick out the values from the problem. My initial pressure is 1.60 atmospheres, my initial volume, 45 milliliters. My final pressure is 0.98 atmosphere, and I'm looking for my final volume. So I plug those in, and I see, aha, to isolate V2 or get V2 all by itself, I just have to divide by 0.98 both sides. So I do that. Now I plug that into my calculator, and I get an answer of V2, my final volume, is 73.5 milliliters. They wanted the answer in milliliters, so I don't have to do any conversion. Let's check to make sure if it makes sense. My pressure decreased, so my volume should be bigger. And sure enough, it is. I hope this video has helped you with Boyle's law. Please don't hesitate to ask if you have any questions. Thank you.